So this is on solving, listen please, this is on solving one-step equations with fractions. So we've done this in several different ways. Yes?
I accidentally got mine.
Okay, go do it. All right, yeah, come on back in for sure. Make sure you get your test signed, and please have those back in the fold on Monday. Unless you have a reason, make sure you clear with me if there's a reason why you can't do that. So, this is an equation, right? X minus 3/7 equals 5/7. We are going to solve it. Let's remind ourselves of what solve means. What does solve mean, folks?
Figure out the answer?
It's more specific than that. More specific than that. To find the value for x that makes this a true statement. Remember, please take notes. Go find one. Don't come back till you find one. Walk around the building until you find one. Hey, listen. We're trying to get something accomplished here. So this is a statement. This says when x equals a certain value and you subtract 3/7 by it, you get 5/7. What is that value for x? We're going to do a transformation. Except I left an s out of there. Why is this causing me trouble?
It doesn't like it.
Doesn't. It's kind of caught in. Let me pause this for a second while I get the smart board working properly. Okay, so I'm going to do a transformation. I left an S out of there, so let's make sure we get that S in there. So, solve using a transformation, show an equation check. So, first step is if I'm going to get x by itself, which is my goal here, that's why they call this a one-step equation, I'm going to add 3/7 to both sides, yes.
Isn't it x equals 3 plus 3? No, 3/7 over. No, okay. Isn't it x equals 3/7 plus 5/7?
Right, that's what I just did right there, okay? So that equals 8/7, right? And
3 plus 3 doesn't, that's 3/7 plus 3/7.
5 plus 3, right? And you add the numerators, so that's 8/7. You don't add the denominators, right? Okay, now, you have to do it this way with a transformation. Some of you still aren't doing this when you're solving equations, and that's causing you to lose points. Some of you, I'm not sure you know what a transformation is at this point. What is the transformation up there? Adding 3/7 to both sides, that's right. And so because when we get to multi-step equations, you won't be able to do these in your head, and so that's the reason. Now let's do a check. So the check is, this is our solution. When we said solve, this 8/7 is our solution, but we want to check to make sure that it works. So we plug it back in. I plug the 8/7 back in for the x, and then I put this in a question mark form, and in a question form, does 8/7 minus 3/7 equal 5/7? I legitimately ask myself that question, and I answer the question in the next line. I say, yes, it does, by putting a check next to it. So that is a true statement. Therefore, this is the value for x that makes this particular equation true. All right, any questions on that? All right, so let's go on down to the next one. Still isn't working quite right. All right, let me get rid of all this. Thought I'd cleared that out of there. Okay. All right, so 4/9 plus r equals -1/2. So this time, I've got a couple of issues in play here. I can't just go into my transformation. What do you think I should do first before I do a transformation? Bridge?
LCD.
LCD, very good. So I'm going to ask myself what the LCD of 9 and 2 is. And what is that? 18. So that's what I'm going to work with. Before I do any transformations, I'm going to change 4/9 to what? 8/18 plus r, and I'll change -1/2 or -1/2 to -9/18. And I strongly recommend keeping the negative in the numerator. Now, once again, I have something more than R. I want to get R by itself. So what should I do to get R by itself? What kind of, this is where,
Subtract 8 over
818
from both sides, right?
Yeah.
Now, and then that would get, so I'm going to show that in the form of a transformation. So subtract 8/18. And let's remember, when I'm subtracting from a negative number, I'm moving left on the number line, right?
Yes.
When I'm subtracting, so where am I ending up here with R?
17.
Negative 17/18. Now we'll check it. Now I'm going to leave, when I'm doing my check here, since I really want to know if this works, I'm going to have 4/9, a negative 1/2 in there with their denominators of 18. That's okay to do that, and really it's necessary to do that. So I have 8/18 plus negative 17/18, and put parentheses whenever you have a sign and
negative.
a negative number. So it's plus negative 17/18. Does that equal, I'm going to use negative 1/2 with a denominator of 18, so negative 9/18.
Yes, it does.
Yes, it does, because 8 plus negative 17 is negative 9/18. And you know that that equals what? Both sides equal negative 1/2. So now I can circle my solution. All right? Got it?
Yes.
With all those procedures, just like so, right? Plugging in and then not finishing the check is not really doing your check. All right.
Let me close the door.
Yes, that'd be very helpful. Okay.
Very helpful.
So, let's go 3/14 plus t equals negative 2/7. So what do you think I should do here? Yes.
When we do t, when we do 3/4 plus t, I know you like the variable lowercase, but the t kind of looks like a plus.
Right. I posed this problem. Yeah, I would never do that to you on a test. Use a t, because that is very confusing. I got these from the PowerPoint that comes with the textbook. So, yeah, I'm sorry about that, but we'll roll with it here. What's my least common denominator this time?
14.
Good.
14 plus R equals 4.
And of 7 is, I'm sorry, it's 4, yeah, that's right, is 14, right? So I leave this alone, right? And then plus t equals, and what am I going to make this?
4/14.
Negative, right? Negative 4/14. Now I have to subtract what from both sides?
3/14.
Subtract 3/14 from both sides. Again, I'm going, this problem's similar to that last one. And I have what? What is it? T equals negative 7/14, or what? Negative 1/2. Now, I'm going to leave it in the negative 7/14 form when I do my check. So I got 3/14 plus what?
Negative 7/14.
Negative 7/14. And does that equal negative 4/14, right? Yes, it does. Equals negative 4/14. Check it and circle it. I'd let you circle that since I simplified it. This is the real solution, negative 1/2. It's solved. Now, in the next problem we have now, it's a little different, right? You really have to make sure. I definitely have kids that never get out of the addition and subtraction mode. This is negative 3/8 being multiplied by x. The way I'm going to deal with this is I'm going to multiply by the reciprocal. Remember, reciprocal is reciprocal of, let's say, 3/2 is what? 2/3. Because what makes something reciprocal, it's the number you multiply another number by to get 1, right? That's the key. So let's do another. What about the reciprocal of a negative number? Reciprocal of negative 5/9 is what?
Negative 9/5.
Negative 9/5, right? Because negative 5/9 times negative 9/5 is equal to 1. Right? So that's the key. So whenever you're saying what a reciprocal is, it's not that flippy thing, or definitely don't say the opposite. It's not the opposite, right? So Jennifer, what's the opposite of negative 1/2? Right, okay. What's the reciprocal of negative 1/2? Right, very good. Let's-
Negative.
Yes. Jennifer. So negative 2, right? So what do we notice? That reciprocals have the same sign. That's huge. Talk about something you want to write down in your notes that's really, really important. Reciprocals always have the same sign. So a positive number has a positive reciprocal. A negative number has a negative reciprocal. So if I want, on this particular problem, I'm going to multiply by the reciprocal of negative 3/8. I'm going to go ahead while I'm here. I'm going to rewrite this problem in improper fraction form, so that's 9/4, right? Now I'm going to do a multiplication transformation. I'm going to multiply both sides by the reciprocal of negative 3/8. Why am I using multiplying now as opposed to addition and subtraction like I did before?
Because you have a multiplication problem.
Yeah, because negative 3/8 is being multiplied by x, it's not being added or subtracted from it. So what am I going to multiply here?
Negative 8/3.
Negative 8/3, right? And I'm going to go ahead and put that negative over here in the numerator. Okay, so how do I clean this up? This is all just what on this side? X, right? Now, how about over here? Any canceling? Can I do any canceling?
Yeah.
That's
Okay.
why.
Who says yes?
Me. I do.
Justin. What canceling can I do?
Okay, so you can do 3, the 3's there.
And
3 to
that-
9,
this will
then
be
the
the
4
one,
to
right?
the 8.
And what gets left behind when I cancel a 4?
A 2.
2.
A negative 2, right?
Yeah.
So, what's left? I've got 3 times negative 2 over 1 times 1, right? So what's that all going to equal? Negative 6, that's right. Now let's check it. So I say, does negative 3/8 times, if I want to, I could put that 6 over 1. That's not, ooh, I got to put negative there, right? Does that equal 9/4? Well, let's see, the 2 negatives make a positive, so that's going to be good, right? So I really don't even need the negatives in there, so just kind of disregard those. But now what do I have? If I cancel out the 8, what do I have? 8 and the 6,
4 and
4 and 3.
4 and 3. So I get 9/4, right? 9/4 equals 9/4, and I'm done, right? And I can circle my solution.
Sir,
Ananias?
you want us to, when we're checking, you actually want us to show how it equals 9?
Yeah, because otherwise I think you're just going through the motions. The check is for you, really. I know I'm requiring it, but it's really my great gift to you to help you get the right answer, okay? All right? Because, you know, it really will help you if you authentically do it. Don't do it for me, do it for your country.
America.
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 Okay. So, all right, I'll pause this and tell you my favorite oh shoot, I only got 5 minutes. Remind me to tell you my favorite Star Spangled Banner.
Oh no, just tell us right now. What time?
Man, I got 5 minutes to get through this. I'll tell you with 1 minute left, all right? Tell you my best Star Spangled Banner joke. All right, now, so what do you think I should do here before I try to do any transformations?
Turn forward to a
So that's 45 plus 8, which is what?
53.
53/9, right? Now, what kind of transformation am I going to do here? What's reciprocal? 4. So I'm going to multiply 1/4 on both sides, right? Now, notice that nothing really cancels out here, right?
Multiply.
So I'm just going to have a little bit of a messy answer of 5336, right? That's kind of messy looking. That's all right. We'll see if it works. We're not sure yet. 4 times 5336, does that equal 53 ninths, right? Well, you can see it cleans up pretty well. If I cancel a 4 and I got a 9 right there, right? There's their 53 ninths. So 53 ninths, sorry, I've got this new watch and it, I haven't figured out how to use it yet. Okay, so this equals 53 ninths, and that's good, right?
Yes.
And so that checks up. All right, let's,
You can skip that one.
I know you want to hear my story, but I said with 1 minute left, I'm going to show you one word problem. I got to show you one more here and one word problem. All right, how are we going to handle this? I got negative 3/4 x equals negative 1/2.
It's gonna be positive because there's two C's.
Multiply by the reciprocal. So what's the reciprocal of negative 3/4?
4
Negative, right? So this is going to be x equals, any canceling over here, go on.
Yeah, yes.
Yes.
2 goes into 2 once, and 2 goes into 4 twice.
Okay, so the two negatives
2/3.
make it positive, so the final answer here is 2/3, right? Check it. I got negative 3/4 times 2/3, does that equal negative 1/2? We know we got the right signs because a negative times a positive equals a negative. Now, does 3/4 times 2/3 equal 1/2? Well, let's look at our canceling. That makes a 2. Those make 1s. So negative 1/2, it looks good here.
Every single color.
Negative 1/2 equals negative 1/2. It checks. Circle your solution. Okay. All right. Let's look at this one word problem. Okay. I know you got, it's actually 2 minutes. I'm going to do this fast. The amount of copper and brass is 3/4 of the total weight. If a sample contains 4 1/5 ounces of copper, what is the total weight of the sample? All right? So we want to say let x, define our variable, equals total weight in ounces. All right? Of the brass. All right? Total weight in ounces of brass in the sample, right? Now, in this particular problem, you're saying 3/4 of the sample equals that, right? So I'll just do the setup on this. What would you do from there? Multiply by the reciprocal, change that to an improper fraction, we'll go from there. So, all right, so let me, okay, well, I know you're much worse in my story than my math. All right, now, okay,
Bye.